right, guys, happy Friday. You made it to the end of the week. That's a great feeling. Today we're going to talk about section 4.2b, which is compositions of functions. So yesterday we talked about function operation, which is things like adding two functions, subtracting two functions, multiplying, dividing two functions. A composition of functions is another thing that we can do with functions, but it's not a regular operation like add, subtract, multiply, or divide. So, a composition of functions is when you substitute one function in for x in another function. I'll give you a moment to jot this down. Now, there's a new notation that you see below our definition of a composition. It looks like it has a lot of parentheses, and when I say this, I'm going to say f of g of x. So we're talking about some function notation. Normally, it's just f of x, and you plug different x's into a function. Like if I said f of 2, I would plug 2 in everywhere I see x. Because we're putting one function in for x in another function, you see that as g of x inside of f of x. So you'll hear me talk about inside and outside functions. So in this case, g of x is on the inside, so that's the one we're substituting. And f of x is our outside function, so we're going to put g of x in for x in f of x. Okay, so remember, composition is not addition, subtraction, multiplication, or division, but rather substitution. So let's actually look at what this means. I have three different functions we're going to work with. F of x is equal to x squared minus 1. G of x is equal to x minus 5, and h of x is equal to 2x plus 3. And letter A down here at the bottom, we're going to do what we saw on the previous screen, which was f of g of x. So it doesn't always have to say f of g of x. You can rearrange the letters, but that's what we're going to do right now. So remember, g of x is the inside function, so g of x is x minus 5, and I'm going to be plugging that in for the x in f of x. So f of g of x is equal to, normally I would say x squared, but I'm going to replace x with x minus 5. So x minus 5 squared minus 1. That's f of x with the other function g of x plugged in for x. Now, I could simplify this. X minus 5 squared is x minus 5 times x minus 5. And I can FOIL that out so that I'll get x squared minus 10x plus 25 minus 1. Combine my like terms and I get x squared minus 10x plus 24. So if you want to FOIL it out, you would come up with a trinomial, x squared minus 10x plus 24. All right, let's try another one. So this time we're going to switch the order. We're going to do g of f of x. So now g of x is on the outside, and f of x is on the inside. So it means I'm going to scroll back up. I'm going to go take my f of x, which is x squared minus 1, and I'm going to put x squared minus 1 where I see x in g of x. So So this is going to look like, normally I would say x minus 5, but in this case I'm going to replace x with x squared minus 1 and then minus 5. Just like when we were evaluating polynomials, I always protect what I substitute with a set of parentheses, but I don't really need the parentheses here, so I'm going to get x squared minus 6 when I combine like terms. So that one's nice because I'm not squaring the thing that I plug in, so I don't have to FOIL it out. Our last example that we'll look at is h of f of x. So now we're going to use that third equation. In this example, f of x is your inside function, so we're going to be plugging f of x in for x in h of x, which is our outside function. So I'm going to go figure out what's my inside function. Again, my inside function is this x squared minus 1. And this time I'm going to replace the x in h of x with x squared minus 1. But I have to leave the 2 and the 3 there. So I would start by saying 2 times, normally I would say x, but now I'm going to replace x with f of x, x squared minus 1, and then finish off my h, that would be plus 3. So h of x is 2x plus 3, but I've replaced the x with the function x squared minus 1. I can distribute to get 2x squared minus 2 plus 3, and then combine my like terms for 2x squared plus 1. And I have just composed two functions. So composing two functions is the process of substituting one function in for x in another function. If you're squaring it, you might expand it and FOIL it out. If you have something that you can distribute or multiply by, like we did in letter C, then you distribute the 2, or you might just be combining like terms, like we are in letter B. You have a homework assignment. It's on your gold sheet. This is not in the textbook, so I just gave you 3 new functions, and you are going to do the following compositions. There are 5 of them. And then on page 171, you're also going to do 47 and 65. So when you finish your concept check, you can go ahead and get started on that homework assignment. Have that done for Monday, and I will see you then.